Hello and welcome to this video lecture series on microwave tubes. In this video, we will obtain expression for velocity modulation. So in last video, we have seen that operation of two cavity klystron amplifier. So for two cavity klystron amplifier, we would like to obtain expression for V of T1. So we said that when electrons entered buncher cavity, there is a presence of RF signal, and because of the presence of RF signal, few electrons will travel with higher velocity, few electrons will travel with the slower velocity depending on the amplitude of the RF signal, and result of that, after traveling a certain distance, they would form a bunch. So in today's class, we will try to obtain the equation for velocity modulation, which is V of T1 for two cavity klystron. So before we start, recall that electrons entering buncher at t equal to T0, electrons exiting buncher cavity at t equal to T1, electrons entering catcher cavity at t equal to T2, and electrons exiting catcher cavity at t equal to T3. So we will write this: electrons entering buncher cavity at t equal to T0, electrons exiting buncher cavity at t equal to T1, electrons entering catcher cavity at t equal to T2, and electrons exiting catcher cavity at t equal to T3. Okay, so to determine V of T1, we have to obtain the average microwave gap voltage. So to do that, we should start with this voltage V0. First we'll write what is V0, then we will write average gap microwave voltage present in this tube, and that voltage we will add with this voltage V0, rather this is velocity, so it is actually 0.593 into 10 to the power 6 under root V0. So in that DC voltage V0, we will add the average microwave gap voltage, so we'll get the velocity of the velocity modulated equation. So that is our flow. Under we will start with this V0. So under equilibrium, static energy is equal to kinetic energy. So static energy is E into V0, and kinetic energy is half m V0 square. This is capital V, this is small v. Small v indicates velocity, capital V indicates DC voltage. From this, velocity is equal to under root of 2e V0 by m. Now, using the constants of electron charge and electron mass, so electron charge we know 1.6022 into 10 to the power minus 19 coulomb, and charge is 9.1 into 10 to the power minus 31 kg. So using these constants, V0 would be 0.593 into 10 to the power 6 under root v0 meter per second. So if you increase this velocity, if you increase this DC voltage, velocity would be increasing. So now to determine average microwave gap voltage, let us assume the RF signal which is present in the cavity gap. So we will assume the signal voltage present in the buncher gap is something like this: time axis and amplitude axis. This is some voltage signal Vs, which is V1 sine omega t. Amplitude is V1 and it is a sinusoidal variation. So this is a microwave signal present in the buncher. So RF signal present in this cavity gap is this signal. Now let us assume this is the grid spacing D, and at time instance t0 to time instance t1, and these are buncher grids. So this signal is signal voltage present in the buncher grid. So this is signal voltage in the buncher gap. Now our intention is to determine V of T1. Okay, so in order to find the modulated velocity, we can determine the average microwave voltage present in the gap. And to determine V of T1, we have two options. We can determine V of T1 in terms of T0 and theta g, as well as in terms of T1 and theta g. So what is T0? T0 is the time at which electrons entering the buncher cavity, and T1 is the time at which electrons exiting from the buncher cavity. And what is theta g? Theta g is gap transit angle, which we have discussed in our earlier videos. So V of T1 expression can be obtained in terms of T0 and theta g, or T1 and theta g. I will obtain in terms of T0 and theta g, and also will let you know that how you can obtain in terms of T1 and theta g. So first we have written for V0. Now write for average microwave signal present in the buncher gap. Before that, what is gap voltage? Gap voltage between the buncher grids. So that voltage just now we have drawn, which is this: Vs is equal to V1 sine omega t. Now we will obtain average microwave signal present in the buncher gap. So that to determine the average microwave signal present in the buncher gap, first we'll write average average transit time through the gap. So the transit time is tau g. So it is tau. It is distance upon velocity. So d is the separation between grid, and velocity is v0, and that is again t1 minus t0. Why I am writing t1 minus t0 is because this is t1 minus t0. So this is the transit time for electrons in this particular buncher cavity gap. Okay, so average gap transit angle would be now average gap transit angle. So multiply this time with omega, so omega tau is equal to omega into t1 minus t0 is equal to omega d over v0, and which is actually theta g, right? So one must consider that this v1 is having very small amplitude in comparison to v0. v1 is very small as compared to v0. Otherwise this v1 has to be also considered to write for transit time. So this transit time is approximately equal to d by v0, where we assume that this v1 is very small. Okay, so this is transit time and gap transit angle. Now we'll write for average microwave signal. Average microwave voltage in the buncher gap. It is Vs. So average signal, how do we write average signal? Area under the curve upon base. So using that information, we'll write the signal is V1 sine omega t. So that is the signal. So we'll take the integration of this to determine average value. T0 to T1 is the time over dt, and the base is 1 over tau, so that is transit time. So this is average signal. How do we determine? So let us integrate this. To integrate, we have to multiply and divide by omega, so that it is 1 over omega tau t0 to t1 v1 sine omega t d omega t. Now it is in the form of sin x dx. Integrating, Vs is equal to integration of sin x dx is minus cos x. So using this formula, it would be minus v1 is the constant out of the integration, omega tau cos omega, putting the limits, omega t1 minus cos omega t0. So we have taken the integration. Now just rearrange the terms. I can write v1 over omega tau. This minus would become plus. I will write t0 term first. Omega t0 minus cos omega t1. So now what we have, this is cos minus cos. So let us try to have this as cos a minus b and cos a plus b. So we wanted to use a trigonometric identity using, or we'll write to use a trigonometric identity. Cos a minus b minus cos a plus b is equal to 2 sin a sin b. So what should be A and what should be B? So we will assume, or let A is equal to, let us assume A is equal to omega t0 plus omega d by 2v0. But how do we do that? Let me tell you. What we have written is this: omega t1 minus t0 is equal to omega d by v0. That is, we already written omega t1 minus omega t0 is equal to omega d by v0. So always we can write omega t1 is equal to omega t0 plus omega d by v0. Okay, so replace this omega t1 with this. Where we have omega t1? This quantity. So first, before using this, let us replace this, and then we will assume. So Vs is equal to V1 over omega tau cos omega t0 minus cos omega t1 will replace with omega t0 plus omega d by v0. Omega t0 plus omega d by v0. Okay. Now, as we said that we'll use a trigonometric identity, and this would be a minus b and this would be a plus b. So now we'll assume, let a is equal to omega t0 plus omega d by 2v0, and b would be omega d by 2v0. So rather, this omega d by v0 is theta g. Okay, anyways, so let us see what is a minus b. If you do a minus b, it is omega t0 plus omega d by 2v0 minus omega d by 2v0 is it is omega t0. So this is a minus b, and what is a plus b? So you see omega t0 plus omega d by 2v0 plus omega d by 2v0. So it would be omega t0 plus omega d by v0. So we can replace this with 2 sin A sin B. Therefore, average microwave voltage is V1 or omega tau 2 sin A sin B. This term would be replaced as 2 sin A sin B. And what is A plus B? We have discussed. This is A plus B. So 2 sin A. A is this omega t0 plus omega d by 2v0 into 2 sin A sin B, and B is omega d by 2v0. This V is small. Okay. Now just rearrange the term and using omega tau. Tau is d by v0, so omega d by v0. So this tau will replace by d by v0. Vs is equal to v1 or omega d by v0 to sin omega t0 omega d by 2v0 sin omega d by 2v0. Now what we'll do, we'll just take this 2 to the denominator. We'll just rearrange the equation. Vs is equal to V1 over omega d by 2 V0. This 2 we will take here, and this term will write first sine omega d by 2 V0, then sine omega t0 plus omega d by 2 V0. Okay. Now the term omega d by 2 V0, if you remember, it is omega d by V0 is theta g. So omega d by 2, see, omega d by V0 is theta g. If omega d by 2 V0 is, it would be theta g by 2. Okay, since theta g is equal to omega d by 2 v, omega d by V0, then omega d by 2 V0 is theta g by 2. Therefore our Vs becomes V1 sine omega d by 2 V0 divided by omega d by 2 V0 into sine omega t0 plus omega d by 2 V0. So that is Vs is equal to V1 sine theta g by 2 divided by theta g by 2 sine omega t0 plus theta g by 2. This quantity sine theta g by 2 or theta g by 2 is beam coupling coefficient of the input cavity gap. This is beam coupling coefficient of the input cavity gap. And as if you plot the graph between theta g and beam coupling coefficient, you know the best value for beam coupling coefficient is 1, and if you keep on increasing the gap transit angle, beam coupling coefficient reduces in sinusoidal fashion. So that is one control parameter which we have discussed during our explanation of two cavity klystron amplifier. Okay, so this was Vs. We will clearly write here where beta I is equal to sine theta g by 2 or theta g by 2 is beam coupling coefficient of the input cavity gap of the input cavity gap. Therefore now the equation of velocity modulation, finally velocity modulation equation is, what we have obtained is Vs. So we have to now write for V of T1. So this velocity of electrons when they have exited from Buncher gap is actually, as we have started or stated in the start, is V0 is actually 0.593 into 10 to the power 6 under root V0. So that DC beam voltage V0 plus Vs, which is the average gap voltage which we have determined. So this velocity is written as this V0, what we have written, if you remember, is this V0 is 2E V0 by M. So average microwave gap voltage has to be added in this DC voltage. So V of T1 is under root of 2E by M V0. This is DC voltage plus average microwave gap voltage, which is beta I V1 sine beta I V1 sine omega T0 plus theta G by 2. So let us take V0 common. So it is 2E V0 by M inside the bracket 1 plus beta I V1 upon V0 sine omega T0 plus theta G by 2. Okay, so this term is actually V0, and this quantity beta I V1 over V0 is called as depth of velocity modulation. Depth of velocity modulation. So quickly we'll write the final form of this expression using binomial expansion, assuming beta I V1 is very small quantity with respect to V0, using binomial expansion, which is 1 plus a raised to n is equal to 1 plus na plus n into n minus 1 upon 2 factorial a square plus so on, assuming the first two terms, ignoring higher order terms, and applying this for this bracket 1 plus beta I V1 upon 2 V0 sine omega T0 plus theta G by 2 raised to 1 by 2, because this term is in under root. Assuming this is a and n is equal to 1 by 2, so it would be 1 plus na. So n is 1 by 2 beta I V1 to V0 sine omega T0 plus theta G by 2. So this is actual, the term will become. So finally V of T1 is V0, because this term is V0, under root of this is V0, and this using binomial expansion is this term 1 plus beta I V1 upon 2 V0 sine omega T0 plus theta G by 2. So this is expression for velocity modulation in terms of T0 and theta G. The same expression can be obtained in terms of T1 and theta G. So as we have written here, we have replaced this T1 in terms of T0 and theta G. Okay, we can always write this T0 in terms of T1, and this would be as it is T1. So finally we will get expression for velocity modulation in terms of T1 and theta G. That would be V of T1 is equal to V0 1 plus beta I V1 upon 2 V0 sine omega T1 minus theta G by 2. So both forms are possible. Both forms of velocity modulation are possible. One is in form of T0 and theta G, and other is in form of T1 and theta G. So this is what we have obtained for velocity modulation. In the next class, we'll see about bunching process in detail. Thanks for watching.